Welcome, stargazers. Might you at any point trust it? Picture a heavenly event so huge that it creates shaded areas on Earth, apparent even without trying to hide. That is the scene we may be near, the very edge of seeing it in the Orion constellation. The star Betelgeuse is acting strangely, indicating a looming cosmic explosion that will illuminate our sky more than ever. However, when will Betelgeuse go supernova, and what will it look like? According to researchers, what secrets could this heavenly event uncover? Join us as we plunge deep into the details of what's actually the deal with Betelgeuse and the effect it could have on Earth, and maybe for the whole nearby planetary system. Found around 650 light-years from Earth in the Orion constellation, Betelgeuse isn't just any normal star. It's a red supergiant, quite possibly one of the most glowing stars known to us, shining with a brilliance over 100,000 times that of our Sun. But why does this red giant matter so much to us? Well, Betelgeuse stands out for its brilliance, but also for its history and importance in human culture. Named after the Arabic expression Yalal, which means the hand of Orion, Betelgeuse has been noticed and documented by ancient civilizations for hundreds of years. It has been a guide for travelers and a mark of wonder for astronomers, with its ruddy shade distinguishing it from other stars in the Orion constellation. Can you imagine a single star overshadowing our whole solar system? To give some perspective on the sheer immensity of Betelgeuse, if it replaced our Sun, its edges would extend all the way to Jupiter. How could a single star achieve such huge proportions? At 10 million years old, it's significantly younger than our 5-billion-year-old Sun. However, Betelgeuse's enormous size means it burns through its material much faster, predicting a shorter life expectancy than that of other stars. Now, this celestial behemoth, traversing a volume big enough to contain more than 1 billion of our suns, is approaching its final cycle. When stars of such size reach their twilight years, they don't just disappear. They exit with an extravagant flare, a cosmic explosion blast that is beyond human understanding in terms of its energy and brilliance. Such an event has the potential to dominate a whole galaxy, creating shaded areas of brilliance across vast distances. The last time Earth saw a supernova blast this close was in 1964, sometime before the development of modern telescopes. This event, known as the Kepler supernova, was the last supernova to be seen in our Milky Way galaxy with the naked eye. It remained visible for more than 1.5 years, more brilliant than any other star in the night sky, and even visible during the day for several weeks. What secrets do these heavenly remnants uncover to us? Ancient records from various human civilizations, including Chinese and European astronomers, recorded the appearance of this new star. Interestingly, remnants of this blast, in the form of an expanding debris cloud, can still be observed today with complex telescopes, giving us insights into the violent ends of massive stars. Supernovae have been rare for observers on Earth, but imagine for a second a stellar explosion so intense that it rivals the brilliance of a full moon, casting shadows on Earth at night and even being visible during daylight. The radiation from such an event could charge our atmosphere, possibly affecting satellite operations and even the climate. Betelgeuse, with its erratic dimming patterns, suggests it may be preparing for just such a grand display. Could we be on the edge of witnessing one of the universe's most dramatic events? Just recently, astronomers made a surprising discovery. Between October 2019 and mid-2023, Betelgeuse underwent a remarkable transformation that drew the attention of astronomers and skywatchers worldwide. Known as the Great Dimming, the star's brilliance, which had been stable for centuries, began to decline significantly. This sudden change was so noticeable that even casual stargazers saw it. When comparing Betelgeuse to other stars in the Orion constellation, it was clear that something unusual was happening. This means that we're not only hundreds of years away from seeing its supernova blast, but maybe only a few decades or even less. By April 2023, cosmic observations reported that Betelgeuse had returned to its normal brightness levels, leading many to believe that the period of anomaly had ended. In a stunning twist, the following months saw Betelgeuse's brightness intensifying by an astounding half. Such prominent variances, while typical of variable stars, were surprising for a star like Betelgeuse, which had mostly shown predictable luminosity cycles. The sudden and extreme surge in its brilliance pushed the star back into the spotlight, igniting discussions about its future. But what caused this sudden change in brightness? Why did Betelgeuse, one of the most familiar stars in our night sky, suddenly throw a divine curveball? Stars are not just shimmering spots in our night sky. They are dynamic entities with life cycles, behaviors, and mysteries of their own. For some celestial bodies, periodic brightness variations can be expected, akin to the rhythm of Earth's seasons. Throughout its stellar lifetime, Betelgeuse has kept a relatively consistent 400-day brightness cycle. However, with the Great Dimming, it appeared to defy its established behavior, testing our understanding of cosmic phenomena. Now you may be wondering, are we on the verge of a cosmic revelation? While the exact reasons behind Betelgeuse's abnormalities are still under investigation, a compelling hypothesis has emerged. This hypothesis, focusing on stellar activity and mass ejection, presents an intriguing scenario. Picture Betelgeuse as a massive celestial volcano quietly ejecting and expelling vast amounts of its material into space. Recent observations from the Hubble Space Telescope revealed that Betelgeuse had recently expelled a tremendous amount of surface material into the universe. This ejection, a monumental event, was 400 billion times the mass typically released during similar solar phenomena, equivalent to several times the mass of our moon. Such events can result in the formation of a thick dust cloud around the star, affecting its apparent brightness and temporarily making it more challenging to observe. Then, as this dust began to scatter or was driven away by the star's radiation pressure, the veil lifted. This could explain its subsequent return to normal brightness levels. One way or another, these new events suggest a star that's far from done. Astonishingly, many speculate that Betelgeuse may be approaching the twilight of its life, with a supernova event, a sudden burst of energy that can eclipse an entire galaxy in an instant, on the horizon. This phenomenon occurs when there is a sudden change in the star's core. Such changes can arise if a star absorbs too much matter from a neighboring star, or in Betelgeuse's case, from the exhaustion of its nuclear fuel which overflows its mass into the core, setting the stage for a catastrophic collapse. But what drives a massive star like Betelgeuse to its end? Born from the gravitational collapse of gas within molecular clouds, stars like Betelgeuse begin their journey by consuming hydrogen in their cores. This initial phase, known as the main sequence phase, lasts for billions of years and forms the foundation of a star's life. As stars near the end of their hydrogen supply, they expand, adopting new energy sources. In the case of Betelgeuse, as the hydrogen depletes, it begins to burn helium, leading to the formation of carbon and oxygen. This transition from the main sequence stage to the helium burning phase is marked by the star's evolution into a red giant. Over time, as helium reserves decrease, the star undergoes further expansion and shifts into other burning stages, each marked by the fusion of progressively heavier elements. The larger the star, the faster these transitions occur, given the immense gravitational forces at play. Then comes the climax, when iron begins to form in the core. Unlike lighter elements, iron doesn't release energy when fused, so the energy produced is insufficient to counteract the star's own crushing gravity. The star inflates in size, eventually collapsing and triggering a massive rebound explosion, resulting in the explosive force of a supernova. So is Betelgeuse nearing the edge of a catastrophic end, or simply biding its time? Ongoing research by Japan's Tohoku University suggests that the star may currently be in its carbon-burning stage. Lead scientist Hawk believes the core could collapse within a few years once its carbon reserves are exhausted. But not all researchers agree. Studies from Hungary's Konkoly Observatory hypothesize that Betelgeuse is still in its earlier helium-burning stage. The one thing all scientists seem to agree on, despite these debates, is that Betelgeuse is set to become the Milky Way's next supernova. But pinning down the timing of this event remains a vast guessing game, with bets ranging from just a few years to 100,000 years. Amid these scientific discussions and speculations about Betelgeuse's future, one fact remains unchallenged: the very nature of our observations. When we look up at the starry field, there's a subtle paradox we often overlook. This paradox lies in the very concept of time and light. In our vast universe, Stars and celestial bodies are so distant that their light takes an immense amount of time to reach our eyes. For example, the speed of light, while an impressive 186,282 miles per second, still has its limitations. Consequently, the light from distant stars and galaxies takes time to traverse the vastness of space before it reaches us. Looking at Betelgeuse, you're actually seeing a spectacle from 650 years in the past. To put that in context, when this light left on its journey toward Earth, the Renaissance was just unfolding, and adventurers like Marco Polo were mapping out the Far East. In conclusion, Betelgeuse stands as a reminder of the vast, ever-changing nature of the universe, where cosmic drama plays out far beyond our day-to-day lives. While we may not have the precise timing of Betelgeuse's supernova, we can still marvel at its brilliance. It has already provided a glimpse into the beauty and violence that occurs at the end of a star's life. As astronomers continue to study Betelgeuse and its peculiarities, it becomes clear that this star is far from being just an object of scientific curiosity. It also provides a fascinating case study for understanding stellar evolution. The behavior of Betelgeuse could potentially offer crucial insights into how other massive stars in the universe meet their end, especially in cases where observing distant supernovae might not be as feasible due to their distance or obscured visibility. One of the most intriguing aspects of studying Betelgeuse is the ability to track its evolution in real time, something that was not possible for earlier generations of astronomers. Thanks to modern technology, especially the development of advanced telescopes like the Hubble Space Telescope, researchers are able to capture minute changes in the star's brightness, composition, and structure. This allows for a level of observation that was previously unimaginable. Betelgeuse, as it nears the end of its life, has become the focus of intense scrutiny. Its vast size, immense energy output, and unpredictability make it a prime candidate for studying the complex processes that lead up to a supernova. Despite the tremendous distance between Earth and Betelgeuse, scientists have been able to identify a variety of phenomena that were previously observed only in theory. For example, the irregular dimming events that have occurred over recent years could be indicative of internal processes occurring deep within the star's core. This offers a unique window into the inner workings of a massive star in its final stages. While Betelgeuse's behavior has been enigmatic, it's important to note that its supernova event will have consequences that extend beyond just a spectacular display in the night sky. The explosion of a star as massive as Betelgeuse will likely eject massive amounts of heavy elements, which are essential for the creation of planets, moons, and even life itself. Elements like carbon, oxygen, and iron are all created in the hearts of stars during their lifetimes and spread into space during their explosive deaths. This process, known as nucleosynthesis, is responsible for enriching the interstellar medium, which in turn allows for the formation of new stars and planetary systems. For our own solar system, a nearby supernova could have a significant impact. If Betelgeuse were to go supernova, it is unlikely that the explosion would cause harm to Earth directly. The distance between Betelgeuse and Earth is great enough to prevent any immediate catastrophic effects, but the radiation and particles released during such an event could potentially alter our atmosphere. Some scientists theorize that this influx of energy could lead to an increase in cosmic rays reaching Earth. If these rays were strong enough, they could potentially damage satellites, disrupt communications, and even affect living organisms on Earth. In addition, the particles and radiation from a supernova could interact with the solar wind from our sun, potentially causing changes in the structure of the heliosphere. This could lead to alterations in space weather, with more frequent geomagnetic storms that could have long-term impacts on both technology and infrastructure. On the other hand, such a supernova could also present an opportunity for studying the effects of cosmic radiation in a controlled environment, providing a unique experimental setting for understanding how living organisms and technology might respond to such extreme conditions. Betelgeuse's impending supernova event, though still unpredictable, offers a thrilling reminder of the dynamic nature of the universe. The study of stars like Betelgeuse not only teaches us about the life cycles of celestial bodies, but also about the interconnectedness of the cosmos. The elements that make up the Earth and our own bodies are forged in the fiery furnaces of stars, and Betelgeuse's eventual explosion will continue this cycle of creation and destruction, contributing to the formation of new stars and potentially even the next generation of habitable planets. Ultimately, whether Betelgeuse explodes tomorrow or 1,000 years from now, its legacy will live on as one of the most iconic stars in the night sky. It serves as a reminder of the profound scale of the universe and the awe-inspiring processes that shape it, from the birth of stars to their spectacular, cataclysmic deaths. For us, as observers on Earth, Betelgeuse offers both a challenge and a privilege, one that compels us to look up, to wonder, and to continue exploring the cosmic mysteries that lie beyond our world. As Betelgeuse continues to captivate scientists and stargazers alike, its potential to provide new insights into astrophysics remains immense. The study of such a massive star in its final stages is rare, as most stars of this size end their lives far beyond our observational reach. Betelgeuse's relatively close proximity to Earth, coupled with its unusual behavior, makes it an invaluable subject for ongoing research into stellar dynamics, mass loss, and the processes that govern the death of supergiant stars. One fascinating aspect of Betelgeuse's impending supernova is the possibility that it could serve as a cosmic laboratory for understanding how stars interact with their surroundings. The star's immense size and unpredictable nature offer clues into how supergiants influence their local environments, including the surrounding interstellar medium. How do massive stars expel such vast amounts of matter? And how does this material interact with neighboring stars and gas clouds? These are questions that Betelgeuse's behavior could help answer. Moreover, Betelgeuse's explosion will not just mark the end of its own stellar life, but will also serve as a symbol of the ever-changing universe. The light from this cataclysmic event will travel across space, potentially providing future generations with the same awe and wonder that we feel when observing it today.